How you doing, Year 10s, and welcome to another video. This is topic 1.2, how do we organise the elements, where we just look at metals. Let's go. Alright, topic 1.2, how do we organise the elements, the metals? We look at the location of metals, we look at naming groups 1 and 2, and then we look at some trends in metallic properties. So the things you must be able to do, you need to be able to identify some of the properties of metals, state the names of some of the metals, identify the location of the transition metals, state the trend in reactivity, and explain what a metalloid is and an example of a metalloid. So there's two main types of atoms on the periodic table, metals and non-metals, with metals making up the majority of the periodic table. Now, the periodic table is here on the right hand side, and we have this staircase that separates the metals from the non-metals. The left of this staircase is where we will find the metal elements. The right of the staircase is where we'll find the non-metal elements. So the metals make up a large proportion of the periodic table. Groups 1 and 2 are important metals, and then there's a big bit in the middle which is known as the transition metals, and then over the other side we get some metalloids before reaching the non-metals. You have to remember though, hydrogen is the first element on the periodic table, and it's on the metals side, but it's not actually a metal, it is a non-metal. So just be careful with that one. Now, metals have the same sort of properties in common. They are lustrous or shiny. They all appear that way. They're able to conduct heat and electricity. They are malleable, which means they can be shaped. And they are ductile, which means they can be drawn into thin wires. So for example, cans, cars, car parts, they're malleable. Cooking pans, they conduct electricity. They're made of metal. And copper wires, they're ductile. They've been made into wires so that we can generate some electricity. And then also things like lights conduct electricity. So elements in group 1 are known as the alkali metals. So anything in group 1 except for hydrogen is described as an alkali metal. A few of the facts about alkali metals. They form +1 charged ions. Metals like to lose electrons, and elements in group 1 will lose 1 electron to become positively charged. The only way you can become positively charged is if you lose an electron, because an electron is negatively charged. So they form +1 charged ions, which are called cations. They're too reactive to be found as pure elements, and they display extreme chemical behavior. They are very, very reactive. Elements in group 2 are known as the alkali earth metals. So, group 2, beryllium, magnesium, calcium, strontium, they're the alkali earth metals, and they're called alkali because when they react with water, they form an alkaline solution, a basic solution. Group 2 metals, they form +2 charged ions, which are cations as well because they lose 2 electrons. They're not quite as reactive as group 1, and they generally have a low melting point and are relatively soft metals as well. So we need to have a look at some of the trends of group 1 and 2. The trends we need to look at are melting temperature, which is how much energy it takes to turn something from a solid to a liquid. The boiling temperature, which is how much energy we need to give something to turn it from a liquid to a gas. And that's kind of a bit weird for a metal, but imagine just keeping on heating the metal after you've turned it into a liquid and eventually turning it into a gas. Conductivity, how well it conducts electricity, and then reactivity, how reactive it is, and does it what kind of behaviors does it display when it is reacting. So we've got a whole bunch of data below which tells us some information about the melting and boiling points, and also some data on electrical conductivity. So if we have a look at group 1, which is the top bit of this table, lithium, sodium, potassium, rubidium, and cesium, we can see that as we go down the group, the melting point decreases. So one of the trends in group 1 is as we go down the group, the melting point decreases. So does the boiling point. The boiling point of the elements decreases as well. Electrical conductivity, well, there's a little bit of a jump, but in general, they decrease as we go down the group as well. A very similar pattern can be shown for group 2. So the group 2 metals, they display very similar behavior to the group 1 metals. remembering that. So just to sum up, group 1, as we go down group 1, the melting point, it decreases. As we go down group 1, the boiling point, it decreases as well. The conductivity, it also decreases, but the reactivity increases. As we go down the group, the atoms become more reactive. If we have a look at group 2, as we go down to group 2, we see a very similar trend to group 1. So we have a decrease in the melting point, a decrease in the boiling point, and generally a decrease in the electrical conductivity. So just to sum that up, as we go down group 2, melting point decreases, boiling point decreases, conductivity decreases, but reactivity, like group 1, will increase, but not as much as group 1. Alright, we need to be able to explain some of those trends. So explaining those trends for group 1 and 2. So the melting point. Basically, as the atoms of the elements get bigger, they're not able to pack as closely together. So they're not as strongly attracted to the glue that's holding them together. And if you think of these atoms as little spheres, you'll notice that as we go down a group, we're getting bigger and bigger atoms. So they physically can't get close enough together to have a strong attraction. So as we go down, we've got the same charge, but we've got a much bigger sized object, so there's less what we call charge density. The charge is distributed over a bigger sphere, so it's not as charge dense. So going from lithium to rubidium, they're much bigger in size, they can't pack closely together, and they're not as strongly attracted to the electrons that are holding the atoms together, or the metal together. The boiling point. So for the group 1 metals, the attraction between the nucleus and the delocalized electrons decreases due to the decreased distance. It's basically the same as the melting point. What's holding them together is a lot further away the bigger they get. Their radius has increased, the sphere's radius has increased, so it physically can't have a strong enough attraction. The reactivity D increases as we go down, and the reason for this is the electrons are getting further away from the nucleus. So the outer shell, or the valence electrons, are further away from the nucleus, and they can be removed more easily. So if something comes along and wants an electron, it will be able to rip it away from the atom very easily, because that electron can't see or feel the nucleus because it's so far away. So the further that they go out, the further the electrons are away from the nucleus, the easier it is to remove it. The electrical conductivity. The smaller the atom in size, the more of it we would have in a particular mass. So if we have some very small atoms and we have 1 gram, and we have some very big atoms and we have 1 gram, there's going to be a lot more atoms in the smaller sample. So we're going to be able to get better conductivity. The last bit that we need to know for the metals is metalloids. So there are some elements that exhibit properties between that of the metals and non-metals, and these are found along the border between the metals and the non-metals. So remembering our staircase that starts at boron and snakes its way down the periodic table, that separates the metals from the non-metals. Along this border we have what is known as the metalloids. So the metalloids can be seen here in the green, and they exhibit behavior that is more like a non-metal, but they have some properties of metals as well. Most of their properties are considered to be non-metallic. However, metalloids can conduct electricity, and they can be modified to conduct electricity in really precise amounts. One of those is silicon. Silicon is used as a semiconductor and can be found in computer chips, iPhones, pretty much all of your electrical devices. Silicon is both light, it doesn't catch fire easily, but it can conduct electricity under the right conditions. So it's used in computer chips along with germanium because they can control the way that that thing can conduct electricity, which is good for small applications like iPads, iPhones, etc. Okay, topic 1.2, some top tips. Metals are found on the left of the periodic table. They form positive ions, and the metalloids sit on the boundary between the metals and the non-metals. Thanks for watching, guys. Don't forget, drop a like on the video, subscribe for more, and I'll see you next time.